Okay, hey guys. So today we're going to go ahead and do a similar setup as we did last week, where I gave a short lecture that preceded the rest of the information that was provided for this lesson to give us some background. So I'm going to go ahead and start right off sharing my screen so that you can follow along with me. Okay, as a very brief recap of where we are so far, several weeks ago, we started by looking at the rotation or the spinning of the Earth around its axis. We should all know by this point that the Earth spins around a tilted axis of about 23 degrees, and that this rotation of the Earth every 24 hours is what gives us our day. 2 weeks ago, we investigated the revolution of the Earth around the Sun, or the orbiting of the Earth around the Sun. The Earth revolves around the Sun about every 365 days, and this is what gives us our year. And then last week, we looked at the combination of revolution and tilt of the Earth on its axis, and how these two concepts together, linked together, is what gives us our seasons. We showed that when the Earth is tilted towards the Sun, we get summer. When it is tilted away from the Sun, we get winter. And when it's here in between, tilted neither towards or away from the Sun, that's when we get our spring and our fall. Okay, so what's up next for us? So up next for us is the moon. All right, so similar to how the Earth revolves around the Sun, the moon also revolves around our planet Earth. It takes the moon approximately 27 days to make its trip around the Earth. This length of time is actually how we have come up with our concept of a month. But as we know, the moon is not revolving around the Earth while nothing else is happening. While the moon is revolving, the Earth continues to revolve around the Sun. Because of this, by the time the moon makes one complete revolution around the Earth has actually traveled a significant distance around the Sun. This added distance that the Earth has traveled in its own revolution adds an additional 2 days to the amount of time that it takes the moon to get itself all the way around the Earth. This makes our lunar month approximately 29 days. Okay, we can sometimes look at the lunar month in this sort of format. I'm sure many of us have seen a month calendar like, a lunar calendar like this. If we look here, this is August of 2012. This calendar you can see right here is August of 2012. On August 1st of that year, we had a full moon. It took us a full 29 days to get us back to the full moon again on the 30th. So this is a good representation of how our lunar month takes us approximately 29 days. But what's interesting is, why is the shape of the moon changing over the course of the month? Why is it not just a big bright ball all year long like our sun is? Our sun is always big and bright and round. It does not change shape. The reason that the moon changes shape, whereas the sun does not, is because unlike the sun, the moon does not make its own light. The moon is essentially a giant rock that circulates or orbits around the Earth. Okay, it does not create its own light. The light that we see emanating at night in the sky is actually a reflection of the sun's light. The sun shines upon the moon, and the moon reflects that light back to us so that we can visualize it on Earth. As you can see, though, the sun is only going to be able to shine on one side of the moon at a time. So as the moon is making its orbit here around the Earth, the sun is continuing to shine on it, but depending on where it is in its orbit, it's always going to be shining on the one side. This side over here is never going to receive any of the light. We call that the dark side of the moon. All right, so how the sun shines upon the earth, how the sun shines upon the moon, how the moon does not produce its own light, how is that concept linked to the shape of the moon in the night sky? How does that concept create this lunar calendar that we're seeing right here? All right, so the shape of the moon, we also call this the phase of the moon, that we see on any particular night depends on where in the orbit the moon is around the earth. Okay, we're going to look at 4 of these locations in the moon's orbit. 1, 2, 3, and 4. All right, let's start here with number 1. When the moon is sitting between the sun over here and the earth over here in sort of a direct line, or what would be seen as a direct line, the type of moon we see in the night sky is what we call a new moon. Some of you may say, oh, there's no moon in the sky tonight. The moon is always in the night sky. We just can't see it very well. It sometimes appears as more of a very dim halo of the moon, okay? When the moon is sitting in this position between the earth and the sun, it appears dark like this because we are not able to see any of the lighted side of the moon at all. The only side of the moon that we are able to see is the dark side of the moon right here. Okay, this gives the illusion of a very dim or missing moon. Okay, as the moon makes its way further in its orbit up here to the first quarter of the orbit, the type of moon we're going to see in the night sky is going to look like what we would call a half moon. Okay, a half moon is where, from our vantage point here on planet Earth down here, if we were to look up at the moon, we would be able to see half of the lighted side here and half of the dark side here. It gives this illusion of a half moon. Okay? As we progress again further along our orbit over here to where the moon is what we would say is on the far side of the Earth is now sitting between the sun and the moon. At this stage of the moon's orbit, what we are going to be able to see in the night sky is a full moon. And this is because from our vantage point here again on planet Earth, we are seeing the full lighted side of the moon. It gives the illusion of a big round full moon in the night sky. As we progress to the last quarter of the moon's orbit, we are once again going to see what would appear to be a half moon in the night sky, because down here from our Earth vantage point again, we will only see half of the lighted side and half of the dark side. It will, of course, be the opposite half than we saw earlier in the orbit. Some of you might be wondering why the sun and moon do not block one another when all 3 objects are in alignment. So when we have the sun and the moon and the earth in alignment like this, where the moon is between the sun and the earth, how come we see a new moon most months and not a solar eclipse when a solar eclipse is when the moon is blocking the sun? How come most months we see this new moon? Likewise, when the earth is sitting between the sun and the moon over here, how come most months we see a big full moon rather than a lunar eclipse, or when the earth is blocking the sun from making it to, blocking it to the moon, okay? Most months we will see the new moon and the full moon rather than the more rare lunar eclipse and solar eclipse. Why might that be? Okay, the reason why they do not block one another when they appear to be in alignment is because the moon's orbit is actually tilted about 5 degrees off the horizontal. You can see it's kind of at a little bit cattywampus angle here. It's not strictly horizontal. So the objects really don't come into full alignment very frequently. You can see that even when the moon falls between the sun and the earth, it is not in direct alignment most months. And so you'll get the appearance of a new moon. Similarly, when the earth falls between the moon and the sun, because of the tilt of the axis, we're still able to have the sun's rays reach the moon's surface to give us the appearance of the full moon. Okay, so the moon changes its phases based on the relationship between the moon, the earth, and the sun. As we grow from a new moon around to a full moon, we call this a waxing moon. This is when the moon is growing or getting bigger in size, going from essentially nothing to a large full moon. As it's coming back around on the other side of its orbit, from a full moon back to a new moon, we would say that the moon is waning or shrinking or getting smaller. So waxing is getting bigger, waning is getting smaller. Likewise, we have names more than just new, full, and half. We have additional words. So when the moon is less than half of its size, so somewhere between the new moon and the half moon, we call this a crescent moon. This is kind of the characteristic shape of moon that we see in fairy tales and stories. Okay, the crescent moon, it's somewhere between a new moon and a half moon. Likewise, when the moon is somewhere between a half moon and a full moon, we have what we call a gibbous moon. So it's not quite a full moon, but it's definitely larger than half. Okay, so you can have a waxing crescent, meaning it's getting larger and larger as it goes towards a waxing gibbous. And you can also have a waning gibbous. This is a gibbous moon that has come from once being a full moon, and now it's getting smaller as it becomes a waning crescent, and we get back here to the new moon. Okay, so this is a lot of information. If you feel like going back and watching the video again, you're free to do this. What we have discussed today is how the moon revolves around the earth, and this revolution pattern creates phases up, not in the Earth's appearance, but in the moon's appearance. It creates phases in the moon's appearance, right? So I am going to assign 2 additional short videos. One is a twig video, and one is a brain pop video. These will kind of reinforce this information. So it allows you to hear it one more time and another way to help reinforce all this information. Today in our Google form, it will ask you for the secret science word of the day. Today's word is pickle. All right, I'm gonna come off my sharing my screen. Okay, so thank you for listening today. Once again, please go and listen to the twig video and the brain pop video and see if we can just kind of cement this information. I know it's a lot of information, it's a lot of terminology. So go ahead and listen to those videos and work through the remainder of the lesson. And good luck and have a good day.